want to choose our variable to eliminate carefully because we want to make sure that it's the easiest one of the three to eliminate. So in this case here, it looks like they all look relatively easy because here I have multiples of 2 for z. Here I have 1y. That's always a useful thing because I can make 1 into any unit. And here I have 1x. So this one doesn't really seem to matter which variable to get rid of. So I'm going to maybe get rid of the variable z. So again, I'm just going to number my equations because it is very important to keep track of which equations you're working with. Because once you double up equations, you'll end up with all sorts of strange results. So here I'm going to take 3 times equation 1, and so I end up with 9x minus 9y minus 6z minus 42 equals 0. Equation 2 is going to be 5x plus y minus 6z minus 10 equals 0. I'm going to subtract those two. 4x, make sure you're keeping track of your signs, minus 10y, the z's cancel out, minus a negative is plus, so I end up with 32 equals 0. I could simplify this. I might just wait to simplify it, but I'm going to make sure that I label that equation so that I know that it's a new equation. So there's one new equation. I'm going to eliminate equation z by using 1 and 3. So I'm going to do 2 times equation 1. And that gives me 6x minus 6y minus 4z minus 28 equals 0. And equation 3 is going to be x minus 2y plus 4z minus 9 equals 0. And as I add these together, I get a 0 pair for z. That's the one I want to eliminate. So this ends up being, so I'm going to add here, 7x minus 8y, and then this becomes minus 37 equals 0. So looking at these numbers, it might help to simplify these. Well, it doesn't look like it's going to help that much. So what I'm just going to do is I'm just going to get rid of one of these variables, either x or y. It looks like maybe the lowest common multiple. Maybe I will use 40y as my lowest common multiple. So I'll get rid of the y's. So taking equation 4, I'm going to do 4 times equation 4. That gives me 16x minus 40y. That's the multiple I'm looking for. Minus 128 equals 0. Make sure that you multiply every term by 4. Here I need to multiply by 5. So 5 times equation 5 is going to give me 35x minus 40y minus, and then 5 times 37. What will that be? 5 times 30 is 150. 5 times 7 is 35. So I get 185 equals 0. Okay, and then I'm going to subtract these two equations. So I end up with negative 19x. The y's cancel, so I'm going to subtract negative 128 minus is plus. So I'm going to end up with plus, what's that going to be? Plus 57 equals 0. Solving for x. X equals 3. So once I've solved for x, I'm going to back substitute to solve for y. I'll back substitute it into equation number 4. So I get 4 times 3. So this is substituting into that equation. Minus 10 times y minus 32 equals 0. So I end up with 12 minus 32. I'm just going to move the 10 over to the other side. I end up with positive 10y. Just make sure you're keeping track of your pluses and minuses. So negative 20 is equal to 10y, y is equal to -2. Okay, again, once you make a mistake, everything's wrong, so just make sure that your steps are all correct. So I have my first two variables. I'm going to solve for z. I'm going to plug it back into equation number 1 to solve for z. So equation 1 was 3x plus minus 3y, so 3 times 3 minus 3 times -2 minus 2z minus 14 equals 0. There's only one variable left to solve for, so 9 plus 6 minus 14 equals 2z. 9 plus 6 minus 14, that's going to be 15 minus 14 is 1. So z works out to be positive 1/2. There we go. We have our three solutions for that system of equations.